Hello students, Miss Slyman here, and I'm here to talk to you about a little bit of triangle trig, and we're going to start with right triangle trigonometry. So in any right triangle, I name the sides according to the angles and also their location. So the side opposite of the 90-degree angle we always call the hypotenuse. The other two sides are legs of the triangle, and if we put an angle theta here at point A, then we call the side that's opposite of the angle the opposite leg, and the side that touches the angle that is not the hypotenuse the adjacent leg. Now for any triangles, any right triangles that have the same angle degree, the ratio is always going to be the same for the sides. So if I add in, for example, a different opposite here, then the ratio, I could call this one A prime and this one B prime, and this little smaller hypotenuse C prime. Well, the ratio of A prime to C prime is going to be the same as the ratio of A to C. And the Greeks long ago decided to give that ratio a name, and they called that ratio sine. So for example, if this was like a 40-degree angle, sine of 40 is always going to be the ratio that is the opposite side over the hypotenuse. They called cosine the ratio that is the adjacent side to the hypotenuse. So B over C, it's the same as B prime over C prime, and any variety of triangles I could draw that have this same angle. They named the ratio of A over B, tangent. So those are all my ratios. Of course, I could also think of them the other way, C over A, and that one, if I flip them over, the reciprocal of sine, so 1 over sine theta, is of course C over A, and that one we call the cosecant of theta. Cosine, if we flipped that one over, we would call the secant. So there are names for when we flip it over. Tangent, when I flip it over, 1 over tan. That's the adjacent over the opposite. I call that cotan of theta. So this one, if we flip it over, we would get the secant of theta. And that's the little confusing one, that sine turns into cosecant, cosine turns into secant, but so it goes. These you don't really want to know, you don't really need to know. I just wanted to tell you that all of the ratios are covered within trigonometry. But this is only true for right angle triangles. You can only use it for a right angle.